Surya from Sri Venkateshwara College of Engineering from Department of CSE. Today I am going to give you all a presentation on Introduction to ER Diagram. Table of contents. What is an ER diagram? Entity, attributes, relationship, generalization, aggregation, generalization, specialization, inheritance. ER diagram example. What is an ER diagram? An ER, entity relationship diagram, is a visual representation of the structure of a database. It consists of three main components: entities, attributes, and relationships. These components help to define and organize the data within the database. Entity. Entities are represented by means of rectangles. Rectangles are named with the entity set they represent. Attributes. Attributes are the properties of entities. Attributes are represented by means of ellipses. Every ellipse represents one attribute and is directly connected to its entity, rectangle. If the attributes are composite, they are further divided in a tree-like structure. Every node is then connected to its attribute. That is, composite attributes are represented by ellipses that are connected with an ellipse. Multi-valued attributes are depicted by double ellipse. Derived attributes are depicted by dashed ellipse. Relationship. Relationships are represented by diamond-shaped box. Name of the relationship is written inside the diamond box. All the entities, rectangles representing in a relationship are connected to it by a line. Binary relationship and cardinality. A relationship where two entities are participating is called a binary relationship. Cardinality is the number of instances of an entity from a relation that can be associated with the relation. One-to-one. When only one instance of an entity is associated with the relationship, it is marked as 1:1. The following image reflects that only one instance of each entity should be associated with the relationship. It depicts one-to-one relationship. One-to-many. When more than one instance of an entity is associated with a relationship, it is marked as 1:n. The following image reflects that only one instance of entity on the left and more than one instance of an entity on the right can be associated with the relationship. It depicts one-to-many relationship. Many to one. When more than one instance of entity is associated with the relationship, it is marked as n:1. The following image reflects that more than one instance of an entity on the left and only one instance of an entity on the right can be associated with the relationship. It depicts many to one relationship. Many to many. The following image reflects that more than one instance of an entity on the left and more than one instance of an entity on the right can be associated with the relationship. It depicts many to many relationship. Participation constraints. Total participation. Each entity is involved in the relationship. Total participation is represented by double lines. Partial participation. Not all entities are involved in the relationship. Partial participation is represented by single lines. Generalization aggregation. The ER model has the power of expressing database entities in a conceptual hierarchical manner. As the hierarchy goes up, it generalizes the view of entities, and as we go deep in the hierarchy, it gives us the detail of every entity included. Going up in the structure is called generalization, where entities are clubbed together to represent a more generalized view. For example, a particular student named Meera can be generalized along with all the students. The entity shall be student, and further the student is the person. The reverse is called specialization, where a person is a student and that student is Meera. Generalization. The process of generalizing entities, where the generalized entities contain the properties of all the generalized entities, is called generalization. In generalization, a number of entities are brought together into one generalized entity based on their similar characteristics. For example, pigeon, house sparrow, crow, and dove can all be generalized as birds. Specialization. Specialization is the opposite of generalization. In specialization, a group of entities is divided into subgroups based on their characteristics. Take a group person, for example. A person has name, date of birth, gender, etc. These properties are common in all persons, human beings, but in a company, persons can be identified as employee, employer, customer, or vendor based on what role they play in the company. Similarly, in a school database, persons can be specialized as teacher, student, or a staff based on what role they play in school as entities. Inheritance. We use all the above features of ER model in order to create classes of objects in object-oriented programming. The details of entities are generally hidden from the user. This process known as abstraction. Inheritance is an important feature of generalization and specialization. It allows lower level entities to inherit the attributes of higher level entities. For example, the attributes of a person class such as name, age and gender can be inherited by lower level entities such as student or teacher. ER diagram example. Suppose you are given the following requirements for a simple database for the National Hockey League NHL. The NHL has many teams. Each team has a name, a city, a coach, a captain and a set of players. Each player belongs to only one team. Each player has a name, a position such as left wing or goalie, a skill level and a set of injury records. A team captain is also a player. A game is played between two teams referred to as host team and guest team and has a date such as May 11, 1999 and a score such as 4-2. Construct a clean and concise ER diagram for the NHL database. This is an ER diagram for the NHL database. Question 2. A university registrar's office maintains data about the following entities: courses, including number, title, credits, syllabus, and prerequisites; course offerings, including course number, year, semester, section number, instructors, timings, and classroom; students, including student ID, name and program; instructors, including identification number, name, department and title. Further, the enrollment of students in courses and grades awarded to students in each course they are enrolled for much to be appropriately modeled. Construct an ER diagram for the registrar's office. Document all assumptions that you make about the mapping constraints. This is an ER diagram for a university registrar's office. Thank you so much for watching my presentation. If you like my presentation, please do like, share and subscribe.